We look upon our world, a tapestry of intricate life and delicate balances. We see the ice caps melting. We feel the summers growing ever hotter. We witness storms of unprecedented fury. The story we are told is one of accident, of unintended consequences born from our industrial age. But what if this was not an accident at all? What if the changes we see unfolding across our planet were not the result of negligence, but of intention? It is a startling thought, one that forces us to question everything we believe we know about our relationship with the Earth. Could it be possible that humanity, or a small, powerful portion of it, is actively and purposefully steering the climate of our world? This question is not one of conspiracy in the typical sense, of secret meetings in shadowed rooms. Instead, it is a question of ultimate control. Imagine a world where a group of nations, or perhaps a consortium of powerful corporations, decided that the Earth's natural climate was no longer suitable for their ambitions. Perhaps they saw it as too unpredictable, too wild, too inefficient for a burgeoning global civilization. They might believe that with our vast and growing knowledge, we could do better. They might look at the deserts and the frozen poles not as natural wonders, but as wastelands to be terraformed, to be made profitable and habitable through a grand and deliberate act of global engineering. This is the heart of the matter. The idea that humanity could, or should, take the reins of the planet's climate system. It moves beyond the accidental warming we are so familiar with and steps into the realm of conscious design. The changes would no longer be a side effect of our existence, but the very goal. We would be transitioning from accidental passengers on this planet to its designated drivers, setting the thermostat for the entire globe. But who would hold the controls? Who would decide what the ideal temperature should be? The very concept is fraught with immense power and even greater peril, challenging the very essence of our place in the natural world. This is not some distant science fiction fantasy. The tools to begin such a project are, at this very moment, being discussed and developed in laboratories and think tanks around the world. This field is called geoengineering. It is born from a sense of desperation, a last-ditch effort to counteract the accidental warming we have already caused. Yet, every tool can be used for more than one purpose. A shield can become a weapon, a medicine can become a poison, and the tools designed to save us from climate change could just as easily be used to initiate it, control it, and bend the planet to the will of a few. The question then becomes a moral one. What would be the justification for such an audacious act? Why would anyone want to deliberately change the climate? The reasons could be as varied and complex as humanity itself. At the forefront might be the pursuit of economic power. Imagine a world where a single nation could control the rainfall. They could bring bountiful harvests to their own lands while leaving their rivals to face drought and famine. This is not just about growing more crops. It is about holding the keys to survival itself. A nation that could guarantee mild winters and perfect growing seasons would become a global superpower overnight, attracting wealth and talent, while others struggled against an increasingly hostile environment. The planet's weather would become the ultimate economic lever. Beyond pure economics lies the allure of strategic and military advantage. A world where the climate is a weapon is a terrifying prospect. Imagine being able to create a super typhoon to disrupt an enemy's naval fleet, or to trigger a deep freeze that cripples their infrastructure just before a planned invasion. Control over the climate could make traditional armies almost obsolete. The battlefield would expand to encompass the entire globe, with storms, floods, and droughts as the new artillery. The ability to manipulate weather patterns could become the ultimate deterrent, a power so immense that it could hold the rest of the world hostage without a single shot being fired. There could also be what some might call benevolent motives, however misguided. A powerful group might genuinely believe they are acting in humanity's best interests. They might see a future where they can eliminate deserts, turning the Sahara into a lush garden to feed billions. They might dream of stopping all hurricanes, saving countless lives and coastal cities from destruction. In their eyes, they are not conquering nature, but perfecting it. They see the Earth as a flawed creation, and they, with their science and technology, are the ones destined to fix it, to create a safer, more stable, and more prosperous world for all, according to their own specific vision of what that world should be. Finally, there is the simple, timeless motive of hubris, the sheer arrogance of believing we can, and therefore should, control everything. For some, the challenge of mastering the Earth's climate would be the ultimate scientific and engineering feat, a monument to human ingenuity. It is the same drive that led us to build pyramids, to split the atom, and to walk on the moon. It is a desire to prove that we are no longer at the mercy of the natural world, but that we are its masters. The goal would be control for the sake of control, to place the final, untamed wilderness of our planet's atmosphere firmly under human dominion, regardless of the consequences. If one were to attempt to control the Earth's thermostat, the sky would be the first place to start. The most widely discussed method is known as solar radiation management. The concept is simple, almost like using a planetary sunshade. The goal is to reflect a small fraction of sunlight back into space before it has a chance to warm the surface. One way to achieve this is by injecting tiny reflective particles, or aerosols, into the stratosphere, the upper layer of our atmosphere. These particles, such as sulfur dioxide, would act like a veil of microscopic mirrors, scattering sunlight and producing a cooling effect across the entire globe. This is not just a theoretical idea. Nature has already shown us that it works. When a large volcano, like Mount Pinatubo in 1991, erupts, it blasts millions of tons of sulfur dioxide into the stratosphere. In the years that followed that eruption, scientists measured a distinct, albeit temporary, drop in global temperatures. The plan for geoengineering would be to replicate this effect, but in a controlled and continuous manner. Fleets of high-altitude aircraft or giant cannons would be needed to constantly replenish this man-made shield, creating a permanent, artificial volcanic winter to dial down the planet's temperature as desired. Another idea for brightening the planet is called marine cloud brightening. This focuses on the low-lying clouds over our oceans. The plan involves fleets of unmanned ships that would spray a fine mist of seawater into the air. The salt crystals from this mist would rise and act as cloud condensation nuclei, tiny seeds around which water droplets can form. This would create clouds with a greater number of smaller droplets, making them whiter and more reflective than normal clouds. By brightening these vast oceanic cloud banks, we could reflect more sunlight away from the Earth's surface, specifically cooling the regions below them. These methods are seductive because they seem relatively quick and affordable compared to completely overhauling our global energy infrastructure. They offer the illusion of a simple fix, a technical solution to a complex problem. If a group wanted to deliberately cool the planet, or perhaps just a specific region, these atmospheric tools would be their primary choice. They could, in theory, be deployed by a single wealthy nation or a coalition, giving them the power to adjust the global thermostat. But turning the sky into a canvas for our ambitions is a project of unimaginable scale and complexity, with no guarantee that the picture we paint would be the one we intended. While the skies offer one avenue for climate control, our planet's vast oceans present another. The oceans are the world's largest carbon sink, naturally absorbing enormous amounts of carbon dioxide from the atmosphere. A deliberate plan to alter the climate could seek to enhance this process dramatically. One of the leading ideas is known as ocean fertilization. This involves seeding large areas of the ocean, particularly those that are poor in nutrients, with iron dust. Iron is a key nutrient for phytoplankton, the microscopic marine plants that form the base of the oceanic food web. The theory is straightforward. By adding iron, we could trigger enormous blooms of these phytoplankton. Just like plants on land, phytoplankton absorb carbon dioxide through photosynthesis. As these massive blooms live and die, a portion of them would sink to the deep ocean, taking the carbon they absorbed with them. There, in the cold, dark depths, the carbon would be trapped or sequestered for hundreds or even thousands of years. In essence, it would be a way of using the ocean's natural biological pump to pull our excess carbon out of the air and bury it at sea, thereby reducing the greenhouse effect. This method has been tested in small-scale experiments, and the results have shown that iron does indeed cause phytoplankton to bloom. Proponents of this as a deliberate climate control strategy envision fleets of ships crisscrossing the oceans, constantly spreading iron dust to maintain these artificial blooms and maximize carbon absorption. They might see this not only as a way to cool the planet, but also as a way to enhance oceanic productivity. However, we have very little understanding of what such a massive and sustained intervention would do to the intricate food webs of the sea. It is a monumental gamble with the largest ecosystem on Earth. Beyond fertilization, other more mechanical ideas have been proposed. One involves building thousands of giant vertical pipes in the ocean. These pipes would pump cold, nutrient-rich water from the deep ocean up to the surface. This would have a dual effect. The cold water would help cool the surface temperature of the ocean, potentially even reducing the intensity of hurricanes, which draw their energy from warm surface waters. At the same time, the nutrients brought up from the deep would also stimulate phytoplankton blooms, absorbing more carbon dioxide. It is a brute force approach, an attempt to mechanically re-engineer the ocean's natural circulation for our own purposes. If such a grand project of climate engineering could be perfectly executed, the potential benefits could appear truly dazzling. One could imagine a world free from the volatility of nature. Famines could become a thing of the past. By controlling rainfall and temperature, we could turn barren deserts into fertile croplands, capable of feeding a global population of many billions. The great sandy wastes of the world could be transformed into mosaics of green fields and forests. Nations previously limited by their arid climates could suddenly find themselves as agricultural powerhouses, leading to an unprecedented era of global food security and prosperity for all. Furthermore, the threat of natural disasters could be significantly diminished. Imagine being able to dial down the surface temperature of the ocean as a hurricane begins to form, robbing it of its strength before it can ever make landfall. Coastal cities, home to hundreds of millions of people, would no longer live in fear of the storm season. The devastating cycles of drought and flood that plague many parts of the world could be smoothed out, replaced by a steady, predictable pattern of weather. In this engineered world, property damage would plummet, insurance costs would fall, and human lives would be saved on a massive scale. It would be a world where humanity has finally tamed the destructive furies of the planet. This control could also open up new frontiers for human habitation and economic activity. The Arctic, for instance, could be carefully warmed just enough to keep shipping lanes open year-round, creating new, shorter trade routes between continents and unlocking vast reserves of natural resources that are currently trapped beneath the ice. Similarly, regions in Siberia or northern Canada could be made more temperate and habitable, opening up immense territories for settlement and development. From this perspective, climate engineering is not just about solving problems, but about unlocking the full potential of the planet for human enterprise. In this idealized scenario, humanity would achieve a form of stable equilibrium with the planet, but one of our own design. We would be the stewards of a global garden, carefully tending to its climate to maximize its utility and safety. It is a vision of a golden age, a utopia built on technological mastery and supreme confidence. It promises a future where we are no longer victims of the planet's whims, but are instead the calm and rational masters of our own environment. It is a powerful and deeply seductive dream, promising safety, prosperity, and a final victory over the unpredictability of the natural world. However, for every dazzling promise of a controlled world, there is a dark and terrifying shadow of potential failure. The Earth's climate system is not a simple machine with levers and dials. It's actually an incredibly complex, interconnected system of systems. And honestly, we understand only a fraction of how it works. Attempting to deliberately manipulate one part of it, such as the amount of sunlight reaching the surface, is almost certain to have unforeseen consequences elsewhere. This is perhaps the greatest danger of all, the unknown unknowns. We simply do not know what we do not know, and in a system as vast as the global climate, ignorance can be catastrophic. One of the most immediate and frightening risks is the potential for termination shock. Imagine we have successfully deployed a stratospheric aerosol shield to cool the planet. This shield would need to be constantly maintained, a continuous project lasting for centuries. If for any reason, be it war, economic collapse, or political disagreement, that maintenance were to suddenly stop, the consequences would be calamitous. The cooling effect of the aerosols would vanish in a matter of a year or two, but the greenhouse gases accumulated beneath the shield would still be there. The planet would experience an incredibly rapid warming, far faster than anything we are experiencing today, giving ecosystems and human societies virtually no time to adapt. Furthermore, who gets to control the thermostat? A technology powerful enough to change the global climate would inevitably become a source of immense geopolitical conflict. What one nation considers an ideal climate, another might see as a disaster. Russia might desire a warmer Arctic to open up its northern coast, but countries in the tropics, already struggling with heat, would suffer terribly. A decision to create more rainfall in one region could inadvertently cause a catastrophic drought in another, thousands of miles away. The climate itself would become a weapon and a source of war, with nations fighting not over territory, but over the very composition of the sky above them. This creates a world of permanent instability, where the climate is held hostage by the most powerful. It is a scenario that could lead to a form of climate colonialism, where a few wealthy nations dictate the environmental conditions for the entire planet, prioritizing their own comfort and prosperity. Smaller, less powerful nations would be left at their mercy, unable to contest decisions that could devastate their agriculture, water supplies, and way of life. The dream of a perfectly controlled world could very quickly become a nightmare of inequality and oppression, where the weather itself is a tool of the powerful. Even if the technical and political challenges of climate engineering could be solved, the ecological consequences could be devastating. Life on Earth has evolved over millions of years to be in tune with specific environmental cues: the amount of sunlight, the temperature, the patterns of rainfall. A deliberately engineered climate would change these fundamental signals, throwing the natural world into a state of profound confusion. For example, injecting aerosols into the stratosphere to block sunlight would cool the planet, but it would not reduce the levels of carbon dioxide in the atmosphere. This creates a bizarre artificial environment that has never existed in Earth's history. This high CO2, low sunlight world would have deeply strange effects. Plants, for instance, might struggle. While they use CO2 for photosynthesis, they also rely on direct sunlight. A dimmer world could reduce the productivity of our forests and crops, even with plenty of carbon dioxide available. And the CO2 that remains in the atmosphere would continue to be absorbed by the oceans, leading to ocean acidification. This process makes it difficult for creatures like corals, clams, and plankton to build their shells and skeletons. We might cool the planet's surface, but we would be simultaneously dissolving the very foundation of the marine food web. Changing rainfall patterns would cause similar chaos. An engineered climate that brings rain to one desert might unintentionally halt the monsoons that billions of people in Asia depend upon for their agriculture and drinking water. Ecosystems are not isolated. They are connected by vast atmospheric and oceanic currents. Stopping the flow of nutrients from one place could starve another. For example, dust from the Sahara Desert is carried by winds across the Atlantic, where it provides essential minerals that fertilize the Amazon rainforest. What happens to the Amazon if we decide to turn the Sahara green? We risk fixing one problem only to create a dozen more. Ultimately, a geoengineered world is a simplified world. It would be a planet managed for a few specific human goals, such as stable temperature and agricultural output. The rich complexity and biodiversity that make our planet so resilient and beautiful would be seen as an inconvenience. The intricate dance of evolution, adaptation, and natural cycles would be replaced by a rigid, human-imposed order. We might succeed in creating a planet that is more predictable for us, but it would likely be a poorer, less vibrant, and far more fragile world. One where countless species, unable to adapt to the new, artificial rules, would simply fade into extinction. The history of humanity's large-scale interventions in nature is a cautionary tale, filled with unintended consequences. We have seen it time and time again. When we introduced the cane toad to Australia to control beetles in sugarcane fields, the toads ignored the beetles and instead became a devastating invasive pest themselves, poisoning native wildlife. When we built the Aswan High Dam in Egypt to control the Nile's flooding and generate electricity, we also stopped the flow of nutrient-rich silt that had fertilized the Nile Delta for millennia, forcing farmers to rely on artificial fertilizers and causing the delta itself to shrink. These examples, though regional, provide a humbling glimpse into what could happen on a global scale with geoengineering. The principles are the same, but the stakes are infinitely higher. If we miscalculate the effects of injecting sulfur into the stratosphere, we cannot simply recall it. The changes could be irreversible, setting off a chain reaction that we have no power to stop. For instance, these same sulfur aerosols that cool the planet could also have a destructive effect on the ozone layer, the very shield that protects all life from the sun's harmful ultraviolet radiation. In our attempt to solve one problem, we could inadvertently recreate another, even worse one. Consider the plan to brighten marine clouds. While it might cool the ocean below, this altered cloud cover would fundamentally change the amount and type of light reaching the ocean's surface. We have no idea how this would affect the behavior of marine life. Whales and sea turtles navigate using subtle cues, perhaps including light patterns. Phytoplankton, the base of the entire marine food web, migrate vertically in the water column based on daily light cycles. A world with artificially brightened clouds is an alien world to them. We risk disrupting migration, feeding and breeding cycles on a colossal scale, with consequences that could ripple through the entire ocean. Every proposed geoengineering solution comes with a long list of such potential side effects. Ocean fertilization could create vast oxygen-depleted dead zones as the massive plankton blooms decompose. Land-based schemes to capture carbon by planting enormous forests could consume vast quantities of water, creating shortages for both people and existing ecosystems. The Earth's systems are intertwined in ways we are only just beginning to comprehend. The belief that we can safely snip one thread without unraveling the whole tapestry is an act of profound and dangerous arrogance. We would be stepping into the role of planetary managers without having read the instruction manual. We stand at a unique and precarious moment in our planet's history. For the first time, a single species, our own, has developed the capacity not just to influence its environment, but to consciously and deliberately re-engineer it on a global scale. The question of whether climate change could be a deliberate act forces us to confront this new reality. The tools are being forged. The motives, from economic gain to misguided benevolence, are easy to imagine. We are approaching a threshold, and once we cross it, there may be no turning back. This forces us to ask the most fundamental question of all: should we? The argument for taking control is rooted in a deep-seated belief in human ingenuity. It is a belief that for every problem, there is a technological solution waiting to be discovered. It sees the Earth as a resource to be managed, a system to be optimized for human benefit. From this perspective, leaving the climate to the chaotic and often destructive whims of nature is irresponsible, especially when we have the power to make it safer and more productive. Why should we endure droughts, floods, and hurricanes if we have the ability to stop them? It is a view that places humanity at the pinnacle of creation as the rightful master of its domain. Yet, there is another, more ancient wisdom. It is a wisdom that sees humanity not as the master of nature, but as an integral part of it. It recognizes that the Earth's climate is the result of billions of years of evolution, a system of unimaginable complexity that has fostered the miracle of life. This view urges humility. It reminds us that our knowledge is finite, and that our past attempts to control nature have often led to disaster. It argues that the solution to our problems lies not in more control and more technology, but in learning to live in balance with the planet's natural systems, in reducing our impact, rather than doubling down on it with ever grander schemes. Ultimately, the choice is one of philosophy. Do we see ourselves as engineers of planet Earth, or as its custodians? Do we place our faith in our own cleverness to build a better world, or do we place our trust in the resilience of the natural world that has sustained life for aeons? The prospect of deliberately engineering our climate is perhaps the greatest gamble humanity has ever considered. It offers the promise of total control, but it comes with the risk of total catastrophe. Before we take such an irrevocable step, we must think deeply, not just as scientists and engineers, but as a species, about our place on this planet, and the immense responsibility that such power entails.